Okay, this is going to be the first video on sequences and series. Okay, you'll get this formula sheet. So you don't have to memorize the formulas. You have to know how to use them, okay? So here's the concept. These first two with the ANs, whether it's arithmetic and geometric, this helps you find terms in the sequence, okay? These ones down here help you find the sum of the sequences, okay? A represents the number of terms. We'll get into how that works. Infinities. The big thing you need to know is R for common ratio, D for difference, okay? All right, so you're gonna have those formulas, so you don't need to memorize those, okay? All right, the first thing we need to talk about is so vital to the whole process is understanding the concept, arithmetic versus geometric. All right, the idea with arithmetic, whether that is a sequence, which this is a sequence when the numbers have commas in them, opposed to a geometric one. Now the idea is the pattern is a common number that these are either added or subtracted by, so they're adding 7. As you can see here, the difference between 2 and 10 is 8, but that's a much bigger difference. So this, what you do, this is, you're going to figure out the rate, which is the second term divided by the first term. So 10 divided by 2, which would be 5. So check the pattern. 2 times 5 is 10. 10 times 5 is 50. And that's how you know it's geometric. Okay? All right? But if you see that there's not a common difference, then it can't be arithmetic. It has the potential to be geometric, but you have to check it. Second term divided by first. All right? This times this is this. This times this is this. Good. It's a geometric sequence. Okay? All right? So we're going to talk about explicit and recursive formulas. Now, here is the concept. Recursive formulas is how the pattern is working. Okay? So the idea is, a recursive is when I go from, all right, so for instance, let's look at this one. This is here to here is plus 6, here to here is plus 6, here to here is plus 6. So this is an arithmetic sequence. Now recursive, the recursive formula is just going to be AN equals, okay, AN minus 1. Now what does that mean? This means previous term. Use your previous term, and in this case I would add 6 to get it, okay? All right. What explicit formula means, it's a formula to calculate I would say further out terms. Okay? You're not looking for what's the next 3. It's like, I want the 20th term, the 40th term, like the 20th term, etc. Something of that nature. Okay? For arithmetic, okay? All right? For arithmetic, the formula for explicit is AN equals A1 plus N minus 1 times D. Okay? Where A1 is the first term, N is the number of terms, and D is the difference, okay? Okay, we talked about that already. Let me do this. Terms, D is for difference. Wow, this is really sloppy. Okay. Now, in this case, the explicit formula, okay, AN equals, here's what you need to fill in, the first term, that is 7, plus N minus 1, and then my difference here was 6, so I put parentheses 6. Now, since that's a positive number, I'm going to put positive 6. Now, let's look at this one. Is this arithmetic or geometric? Okay, well, 4, that's only 8. That's more than 8, so it can't be that. So let's do second divided by first. So that's going to be 3. So let's see. 4 times 3 is 12. Yep, this is a multiplication of 3. Okay, so the recursive is the same way. AN equals AN minus 1. What's the pattern? Okay, so what I put here is the pattern. All right, I'm doing times 3. Now, the explicit for geometric says AN equals A1 times R to the N minus 1. So in this case, it's the same deal. I'm filling in first, and this is my R right here. Okay, so I got AN equals, okay, A1, which is 4, times 3 to the n minus 1. That's considered the explicit formula, okay? All right, so this is the explicit, and that's the recursive, okay? So what's happening here? That's going to be subtract 7, subtract 7, subtract 7. That's an arithmetic one, okay? The recursive formula is AN equals AN minus 1, minus 7 is the pattern. The explicit formula is AN equals, I got A1, which is 95, plus n minus 1. Now, since I'm subtracting 7, I put negative 7, okay? Because I'm actually subtracting 7 as a pattern. Difference doesn't always mean subtract. You could be adding, okay? All right, well, difference here is 100, difference here is 50, so it's not arithmetic. Let's do second term divided by first term, and you want to get a fraction, in this case, which would be 1/2. So my recursive formula is AN equals AN minus 1 times 1/2. My explicit formula would be, use this one, AN equals, my first term is 200, times 1/2, and I put parentheses around it to the n minus 1. And that's how you make those formulas. Those formulas will be vital for us. Okay? So go ahead, you can try these on your own. Big thing, gotta know arithmetic or geometric first. Okay, now, find the next terms, 3 terms, find the 25th term. Now, for this, we still have to figure out, number 1, is it arithmetic? Is it arithmetic or geo? Okay, so in this case, I am adding 8. 20 to 28 is adding 8, adding 8. So obviously, this is an arithmetic deal, okay? So I know arithmetic, all right? Well, it's easy to get the next 3 terms. That's just the recursive, okay? So how would the pattern continue? It would be 44, then 52, then 60. That's easy, okay? Now, to find the 25th term, what I got to do is come up with the explicit formula. Okay, so this is AN equals A1 plus n minus 1 times D. Okay, my A1 is 12, my n minus 1, and my difference is 8. So I'm going to put positive 8. Okay, now to find the 25th term, all you got to do is sub the number 4n. So what that means is A25, which means the 25th term, is 2 times 25 minus 1 times 8. And I just got to calculate that in my calculator. Okay, 12 plus 25 minus 1 times 8. Whoops, too many minuses. Okay, and that 25th term is 204. And that's how you do that. Okay, all right, find the next 3 terms. All right, well, this difference is 7, 14, so it's obviously, all right, so second divided by that would be 2, so times 2 times 2. So that's what we got. We got a geometric one. So what does that mean? The next one would be 56, okay? Next one would be 112. Next one would be 224. Very easy, okay? To find the 10th term, I got to come up with the explicit formula. This is geometric, so I would use this, okay? All right, so I got the 10th term is the first term times 2 to the 10 minus 1. Now, I would subtract the 10 minus 1. So when I do it, I do 7 times 2 to the 9th power. That makes it a lot easier. That's 3584. That would be the 10th term of that sequence. Okay, let's do a couple more. Okay, all right, obviously difference here is 400, then that's 20. That's not the same. So let's do 100 divided by 500, which is 1/5, and we want a fraction. Okay, so I got 4 times 1/5 is 4/5. 4/5 times 1/5 is 4/25. 4/25 times a fifth is 4 over 125. Okay, all right. Now we got to find the 13th term. So this is a geometric. Okay, so 13th term, 500 times 1/5 to the 13 minus 1. Now, when I go to type this in, I'm going to do 500 times. I'm going to put parentheses around my fraction. And when I type this in, I'm just going to do the math myself. That's 12. Okay? And if I hit fraction to decimal, I get 4 over 1953, 125. Okay? Find the next three terms. Okay, this is subtracting 11. This is subtracting 11, subtracting 11. So this is going to be an arithmetic one. So the next one would be 3. 3 minus 11 is negative 8, and then negative 29. Okay, since it's an arithmetic, I gotta find the recursive. I'm sorry, I gotta find the explicit formula. Okay, so I got 13th. Okay, so that's gonna be 47 plus 13 minus 1 times negative 11. I gotta put that negative in there. So 47 plus 13 minus 1 times negative 11. Don't leave out this plus here, because if you don't, the multiplication doesn't work. So the 13th term is negative 85. Okay, very simple. You're gonna see a lot of repetition in this. Okay, so you guys go ahead, find the next three terms of this, and the 10th term, find the next three and the 31st. Okay, find the missing terms of this sequence. Okay, now, arithmetic, they give you a clue here. So now what you want to do, okay, all right, even though you see this, we're going to renumber the sequence. And let me explain. I'm going to cut this off here and here, so I have a start to a finish. So what you want to figure out is, you're going to make a new sequence, okay, all right, where your first number is now A1, okay, and I'm going to count the terms, okay. So in this case, I got 1, 2, 3, 4. Okay, so I got 4 terms. Okay, A1 is 11. Okay, they told me it's arithmetic. Okay, so I can use this formula to help me. Okay, all right, because if I know the difference, that's all I'm going to need. Well, I know I got 4 terms, so I fill that in. Well, A4 is 32. A1 is 11. 4 minus 1 is 3. So if I subtract this, that's 21 equals 3D divided by 3. The difference is 7. So then I can fill this in. This is 18, 25, 32. Well, think about how would I go the other way? Subtract that. That would give me 4. Okay? All right? So after I count the terms, I use the explicit formula. As you can see, the explicit formula, all right, helps a lot. Okay? So what I'm going to do, okay, I'm going to count 1, 2, 3, 4, 5. So I got 5 terms. Okay, so I got A5 equals A1 plus 5 minus 1 times D. Okay, A5 now is 12. A1 is 32. 5 minus 1 would be 4. Subtract 32. That's negative 20 equals 4D. Divide by 4. My difference is negative 5. So what does that mean? That'd be 27, 22, 17, 12. Now if I subtract 5 going that way, I would add 5 going this way. So that'd be 37, 42. Okay, so renumbering a sequence. Okay, so you guys go ahead and try those two on your own. Okay.